This is lesson 5.4, equilateral and isosceles triangles. So the parts of an isosceles triangle, the two congruent sides are called legs. The angle where the two legs intersect is called the vertex angle. The side opposite the vertex angle is called the base. So the side that's different than the legs is called the base. And then the angles along the base are called the base angles. According to the base angles theorem, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if AB is congruent to BC, then angle 2 is congruent to angle 3. And the base angle's converse is the reverse of that. If you start out knowing that two angles are the same, we could now say the two sides are the same. So if angle 2 was congruent to angle 3, then segment AB would be congruent to segment BC. So in example 1, if segment HG was congruent to segment HK, then this triangle here would be isosceles. Segment GK would be called the base, and the two angles that touch the base would be the same. So that would be angle HGK would be the same as angle HKG. For the second part of our problem, we're given that angle KHJ, which is this corner here, is the same as angle KJH, that's this corner here. These two angles both touch side HJ, so HJ is the base, and that would make the other two sides the congruent legs. So that would be segment HK and segment JK. So here's the first check-in. Pause if you'd like. Answers are posted on Classroom. For an equilateral triangle, it's equilateral if and only if it's equiangular. So the two will go hand in hand. If I know that the measure of angle A equals the measure of angle B equals the measure of angle C, which happens to all be 60, then we would know that AB is equal to BC is equal to AC. All three sides would be equal. And the reverse is true. If I started out knowing all three sides were equal, then I would know that all three angles were equal. So measure of angle A would equal measure of angle B, which would equal the measure of angle C. So in example 2a, we want to find the value of the variables. We can see that we have two angles that are congruent here. They're both 78 degrees. So those base angles are congruent. I can say these legs are congruent, which means I could set 4x plus 23 equal to 10x minus 1. So let's subtract our 4x. Let's add our 1 and divide by 6. So we get x equals 4. In the next one, we see that we're given these two sides are congruent. So these are our legs, making this bottom piece the base. And my base angles would be congruent. I'm going to place another 9x minus 25 in this angle. And now I can treat the triangle as being 180 degrees. Take the three different angles that are in the interior, 9x minus 25 plus 9x minus 25 plus 104 is equal to 180. So that's going to be 18x minus 50 plus 104 is plus 54 equals 180. So if I take away the 54 from 180, I get 18x equals 126, and dividing both sides by 18, x equals 7. For example, 2c, I now know all three sides are equal, which means all three angles are also equal, and all three angles are 60 degrees. If 4x plus 8 is one of the angles, and 60 degrees is one of the angles, then 4x plus 8 would equal 60. So we'll take away our 8, and I get x equals 13. The last one of example 2, I again have two sides that are congruent. So these two sides are the legs, making this last side the base, and those two angles the base angles. So if this one was 29 degrees, the other one is also 29 degrees. So let's add these to 180. 11x minus 65 plus 29 plus 29 equals 180. So that's going to be 11x minus 7 equals 180. We can add 7 and divide by 11. We get x equals 17. So here are some for you to try. You can pause if you'd like. The answers are posted on Classroom. For example 3, this requires a little bit extra maneuvering. And it definitely requires us to mark the picture. With these three angles congruent, this triangle KLN is equiangular, which makes it equilateral. So all three of these sides are all the same measure. So if one of them is 4, they're all 4. So immediately I know that y equals 4. The other thing I know in my picture is that these angles are also congruent. So those two angles would be on the base of NM, making these two sides the legs of my isosceles triangle, and they would be the same. Since I've marked this side as 4, this one would also be equal to 4. So we can have x plus 1 equals 4, and we get x equals 3. So this is the final problem for the check-ins. Pause it now if you'd like. Answers are posted on Classroom. But this is actually the end of section 5.4.